are in Introduction to Statistical Learning, and we're just starting Chapter 7 with the conceptual questions. And question 1, and it has a indicator that it's maybe a little bit difficult, but it's not terrible. So here's the question. So it's mentioned in the chapter that a cubic regression spline with a knot at psi, I think that's called xi, I'm going to call it that, was obtained using a basis of the form, x squared, x cubed. And then this expression right here, x minus psi cubed, for values greater, this little guy right here indicates for values greater than psi. Okay. So we're going to show that a function of this form is indeed a cubic regression spline, regardless of these values here. Okay, so that's a mouthful, but we'll just go through these questions one at a time, and that'll be good enough. So we're going to, part A. So we're going to find a cubic polynomial called f1 that equals this right here, okay, this linear function here, such that f of x equals f sub 1 of x for all x less than psi. Okay, express the a, b, c, d terms in terms of beta, terms. Okay, so this one is very easy. So we just have the f1 equals this, which is what we're given. Okay, and then we just put beta naught, beta 1, beta 2, beta 3 in for the a, b, c, d. Okay, so that one's straightforward. But now in part B, we're going to do the same thing, but now we have f2, and f2 is going to cover the domain for which x is greater than psi. Well, we know from the question that when x is greater than psi, we have this additional term here. Okay? So that needs to get factored into our expression here in part B. Okay, so we can start with f2 is, a plus bx plus cx squared plus dx cubed. And then we can just, and we know that this has to equal this guy right here. Okay, right? So we have again, we have this additional term here. So this has to equal this. And so we want to find the a, b, c, d such that f2 equals this, okay? And so the way that we can do that is we just need to expand this final term here, right? So it's 3x minus xi's, or psi's, I can't remember what I was calling it, xi. And then, you carry out the, the multiplication through all of these, and you get this, okay? And so now we have an x cubed term, and so we could lump that with the other x cubed term, right? So we have beta sub 4 times x cubed, so we can lump those x cubed terms here. So we have beta 3 plus beta 4 x cubed, right? And then similarly, now we have beta 4 times the negative 3x squared xi. And so we have an x squared term over here, and so we can lump those x squared terms here. So now we have beta 2 and 3 beta 4 xi, okay? And we do that for the other, for the x and the no x term, okay? And so then we get our final expression here. And so then we get that a is this, b is this, c is this, D is that. Okay, so me, highlighting things on the screen might be a little bit hard to follow, but I'm pretty sure that if you just go through and focus on expanding this term and then distributing, or clumping the terms by the x degree, it will just fall out for you pretty straightforward. Okay, and now the final three parts, C, D, and E, were just meant to show that f of x, which again now is two functions, right? That it's f1 and f2, is continuous at xi, okay? And not only is f1 and f2 continuous at xi, so is the derivatives and the second derivatives. Okay, so this is pretty straightforward. So we just start with f1, here's f1, and f2, and then we just substitute xi in for x. And so I only did it here in this last term, but really every x term should be a xi. Okay, but when we substitute xi in here, right, in the final term for f2, it becomes xi minus xi. Well, that's 0, so that just drops away, and we end up with this expression, which is the same as f1, right? So this is f2 at xi, and this is f1. All right, well, now if we just take the derivative of this guy, of f1, we get this. If we take the derivative of this guy, we get this. Okay. Again, setting x equal to xi, which again I'm only doing for this last term, although it technically should be for all of them. Well then, again, we see that the final term drops out, and we just get that f2 at xi equals f1 at xi. And we just continue the pattern. We get the second derivative now, which is just the derivative of the first derivative, right? We run through that, set x equal to xi, the final term drops out, and we get f2 equals f1. Okay, we'll call that good.